In this question, you are tested on the concept of moments. You are to calculate the total moment acting on the rod. So it's worth noting that when you're asked to calculate the total moment, the whole rod might not be in equilibrium. And if so, you will get a non-zero total moment answer. So let's check whether is this the case for this question. And note where the pivot is, and then look at all your forces to determine what type of moment the force generates. So the 140 Newton force on the left of the rod will want to make the whole rod rotate in a anti-clockwise manner. So that's anti-clockwise moment. Similarly, on the right hand side, the 140 outward force will want to make the whole beam rotate also in an anti-clockwise moment. So the total moments acting on the rod is simply just adding up the two anti-clockwise moment to get 224 Newton meter. Make sure in the answer you have given the number itself, the units, and also the direction of the moments. In this part of the question, it's slightly more difficult because the pivot point is not known. I've talked about this in the previous MCQ, and the technique to solve this kind of question without a clear pivot is actually to just take any of the points on the rod as the pivot point. And this is true if the rod is not moving inside equilibrium. So I will do that, and I will let S be the pivot point. So if I let S be the pivot point, I can then investigate all the remaining forces and find out what type of moments they create. So the 180 Newton downward force in the middle will want to make the whole rod rotate in an anti-clockwise direction about the pivot point. The values are there for you to check. The outward force R will want to make the whole rod rotate in a clockwise manner, and the values are there for you to check too. So we have just to put everything into a POM equation to get the tension force of R to be 120 Newton. So again, as I've mentioned in the previous question, whenever you see a question without a very clear pivot point, what you have to do is to just check if the object is at equilibrium. If it is, you can take any of the points on the object to be the pivot point, like what I have done in this question.